Hello guys, welcome to another video. Today we're going to work on topic 5 about electricity and magnetism. Multiple choice questions. Let's jump into it and see the solutions of the problems. So number 1. Charge flows through a liquid. The charge flow is made up of positive and negative ions. In 1 second, this is important, 1 second, 0.1 coulombs of negative ions flow in the one direction and 0.1 coulombs of positive ions flow in the opposite direction. What is the magnitude of the electric current flowing through the liquid? Now what we know is that current is the rate at which charge moves through an area A. So if, let's say, this is my fluid inside a tube or something, what do I have here? I have positive ions that they will move in this direction, and I have also negative ions that they move in the opposite direction, like so. But what do I care is I care about how much charge it passes through a cross-sectional area A, like so. So if you can see here, the negative charges, they will pass through this direction, the positive charges, they will pass through that direction. So now in order to find the current, you need to add the absolute values of your current, and you need to divide by the time that it's needed. In our case, the time is 1 second. So if you do the math here, you're going to have 0.2 amperes. So the correct answer here is D. Number 2. A particle with a charge Ne is accelerated through a potential difference V. What is the magnitude of the work done on the particle? We know that the potential difference, it comes from the work done divided by the charge. So if you solve this relationship for work done, you will have potential difference times Q. And the total charge is N times E. So it's V times N times E. So from here, your correct answer is B. The number 3. What is the unit of electric potential difference expressed in fundamental SI units? Now, as we said before, we have to work with this formula. Potential difference is work done over charge. We need to find the fundamental units of work done. That is force times distance, so it's kilograms times meters per second square times meters. And we need to find also the fundamental units of charge. Well, coulombs are not fundamental, so we need to express the charge through the current and the time, that both of them are fundamental. So from here you need to solve for Q, and it's current times time, and the units for that is amperes times second. So for charge, you have amperes times second. So if you combine those together, you will have kilograms times meters square times second to the power of negative 3 times amperes to the power of negative 1. So of course, the correct answer here is C. Now let's move to 5.2. It says that the resistance of component X decreases when the intensity of light incident on it increases. X is connected in series with a cell of negligible internal resistance and a resistor of fixed resistance. The ammeter and voltmeter are ideal. What is the change of the reading on the ammeter and the change in the reading on the voltmeter when the light incident on X is increasing? So we know when the intensity is increasing, then the component, the resistance of the component X is going to decrease. Now from here, let's see what is happening in this resistor, because the current, it flows in this direction. So if the resistance in component X, it will decrease, this is going to increase your current. Now in this resistor, if I use the Ohm's law, I see that when my current will increase, then my potential difference, it will increase. So the potential difference here, at this part, is going to increase. So if this is going to increase, then the Vx, the potential difference at the X component, it needs to decrease, because the EMF here is going to give you a specific value. So what is happening? The ammeter reading is increasing. So here you have either A, either B, and the voltmeter reading is decreasing, either A, either C. Of course, your answer is A. Number 2. 3 resistors of resistance 1 ohm, 6 ohms, and 6 ohms are connected as shown. The voltmeter is ideal and the cell has an EMF of 12 volts with negligible internal resistance. What is the reading on the voltmeter? So you see that the voltmeter here, it reads this potential difference between the EMF and the resistor. Also, it's the same thing if you say that it reads the potential difference between the two resistors that they are in parallel connection. So first what we need to do is to find the current that it flows inside this circuit. In order to do this, I need to have the total resistance. So as you can see, I have two resistors in parallel. So I'm gonna add those together using this formula. And also I have one more resistance in series. So I'm gonna add this as well. I have no internal resistance. So if you do the math here, what you get is 36 over 12 plus 1. So it's 3 plus 1. So it's 4 ohms, the total resistance on your circuit. Now you want to calculate current, so the current, it will be the EMF over the total resistance. EMF is 12, total resistance is 4, so you have 3 amperes for current. So now the potential difference, let's say that it passes through here, through the two resistors, let's call it V6, whatever. It's gonna be given by the Ohm's law, so it's the current times the resistance that is here. So this is the combined resistance of these two resistors that they are in parallel. So from here you have 3 times 3, because this is your resistor, it's just 3. So this will give you 9 volts. Correct answer D. The number 3. It says, in an experiment to determine the resistivity of a material, a student measures the resistance of several wires made from the pure material. The wires have the same length but different diameters. Which quantities should the student plot on the x-axis and the y-axis of a graph to obtain a straight line? So here we need to work, of course, with the resistivity of a material that is given by the resistance times the area divided by the length. Now what we have here, the resistivity will be constant, the length will be constant. So we need to create a relationship from these other ones, from the diameter and the resistance, in order to see what we have to plot in the x and y axis. So from here, what I'm gonna do, I'm gonna take the constant numbers in one side, and I'm gonna solve now for one of those. Let's solve for A, so it gives you rho times L times 1 over R. Well, this is rho, okay? This is the Greek letter rho, it's not E, it's the resistivity. Sorry about that, because like my Greek letters are a little bit different than what we are used to. So this relationship is Y is equal to A times X. So you can see that this is the constant part, the A, so Y it's the diameter, so it's the area, so it's the diameter square. So in one axis you want to have diameter square, and in the other axis you want to have the 1 over R. So of course, correct answer is C. Number 4. We have a wire of length L is used in an electric heater. When the potential difference across the wire is 200 volts, the power dissipated in the wire is 1000 watts. The same potential difference is applied across a second similar wire of length 2L. What is the power dissipated in the second wire? So we know that power dissipated, it can be given by V square over R. I'm working with this formula because I have the potential difference. Now, I need to see what is happening to the resistance. So the resistance, it can be written with the resistivity formula, rho, the resistivity times the length divided by the area, if you rearrange the resistivity formula. So from here, what you have in your next part, you double the L. So you take rho times 2L divided by A. So you can see that your new resistance now, it's double the resistance before. So from here, if you double the resistance, you need to halve the power if you want this formula to still be correct. So from the 1000 watts, it needs to be halved, so it's gonna be 500 watts. The number 5, It says 3 resistors are connected as shown. What is the value of the total resistance between X and Y? So what we want to do here is actually to add all these resistance based on these 2 points. So you see that you have this 3 ohms and this 3 ohms resistance in series connected, and the addition of those, it's connected in parallel with the other resistance of 2 ohms. So first we need to do, of course, 3 plus 3, it's 6 ohms. It's the first resistance combined by those 2. And then, of course, you have to add 6 times 2 over 6 plus 2. And this will give you 12 over 8. So this is 1.5 ohms, the total resistance of this circuit. So answer A. Now let's move on topic 5.3. What do we have here? We have the diagram that shows a resistor network. The potential difference between X and Y, it's 8 volts. So from here all the way here. What is the current in the resistor of 5 ohms? So now you know, so when the current comes in this direction, let's call it I, it's going to split in the 2 different directions, I1 and I2. What I care about I2, the current that passes through this wire. So what I need to do here, I know the potential difference is the same, so it's 8 volts. So working with Ohm's law, it's going to be V over R. But here R, it's not going to be the 5 ohms because you have another resistor with 3 ohms that you need to combine them. So it's going to be 8 divided by the combination of those 2 that they are in series, 5 plus 3, so it's 8 over 8, it's 1 ampere. So correct answer A. Number 2. 5 resistors of equal resistance are connected to a cell as shown. What is correct about the power dissipated in the resistors? So now let's see what is happening. From here you know that a current is going to pass through that way, through your circuit. Inside this combination of resistances, it's going to split in different ones. But now, let's see first in which combination here of resistance more power will be dissipated. What I need to do, I need to work with a formula of power that is equal to I squared times R for these 2 different combinations. Now, you see that the current, of course, is the same, that it passes through them, but you have more resistance in the second part. So that means that more power will be dissipated based on this formula, more resistance, more power will be dissipated in the second one. So of course it cannot be number A, that the power dissipated is greatest in resistor X. Of course it cannot be D either, because you see that there is a difference between those. Now in here, in the second part, we need to see what is happening between Y and Z. Now you know that the current here, it will split in the 2 different ones. So you cannot really work with the same formula again. You have to work with the formula of the same potential difference, because the potential difference here, it's same. So now you see from here that the more resistance that you have, the less power that you have. So more resistance, of course, it's in the upper part. So less resistance in the Z resistor, more power dissipated. So it's not B, your correct answer, it's C. Number 6, it says that a wire of uniform circular cross-section is replaced in an electric circuit. The new wire has the same length and same resistance, but half the diameter of the old wire. What is the ratio between the resistivity of the new and the old wire? So what we know now is that the resistivity is given by ρ is equal to R times A over L. Now from here, the new resistor, the new resistivity of your new wire, it's going to be with the same resistance, with different area, because you have half the diameter, divided by the same length. Now we need to express the area in terms of diameter. The area is pi r squared. So for the first resistor, it's going to be P d over 2 squared, half the diameter squared. So from here you have pi d squared over 4. Now in your new resistor, it's going to be the new radius because you have a new diameter. So your new diameter, it's half of the one before. So it's d over 2 over 2 and all of it square. So this one, it gives you pi d over 4 square. So your new diameter, it's pi d square over 16. And now if you take the ratio between the new wire over the old wire resistivity, what you have here, you have for the new one, you have R times pi d square over 16 divided by L, and for the old one you have R times pi d square over 4 divided by L. And from here you see that all of these, they cancel out and you end up with a ratio of 4 over 16. So this one is 1 over 4. So the correct answer here is A. Number 7. A circuit is formed by connecting a resistor between the terminals of a battery of electromotive force 6 volts. The battery has internal resistance. Which statement is correct when 1 coulomb of charge flows around the complete circuit? A. 6 volt is the potential difference across the resistor. Of course it's not. The EMF is 6 volts. Okay, we have also internal resistance. 6 joules of thermal energy is dissipated in the battery. Well, this is incorrect because we have also the resistor in the system. 6 joules of chemical energy is transformed in the battery. That seems correct, like the change in energy from chemical to electrical inside a battery. 6 joules of thermal energy is dissipated in the resistor. This is also incorrect as B was incorrect, so your correct answer here is 6. Now this part, it's based on 5.4. It says, number 2, a proton of velocity v enters a region of electric and magnetic fields. The proton is not deflected. An electron and an alpha particle enter the same region with velocity v. Which is correct about the paths of the electron and the alpha particle, if it is deflected or it is not deflected? So what we have here? We have a proton that is entering with a velocity v into a region of electromagnetic fields. So what is going to happen if the proton, it will not be deflected? That means that the total forces on it, they're going to be 0. So if the electric field, let's say, it creates a force in this direction, then the force of the magnetic field, it needs to be in the opposite direction, equal in magnitude, so this proton, it doesn't deflect. Now it's the exact same thing with the alpha particle because it has also positive charge. So it's going to be the same. The forces will be different, of course, of a proton, but it doesn't really matter. They will be in the opposite direction, equal in magnitude. So the alpha particle, it will not be deflected. Now what's going to happen with the electron? Let's see the electron situation. The electron situation, it will enter the electromagnetic field with a velocity v. Now the forces that they will act on the electron, they will be again exactly the same. But the only difference is going to be that the magnetic forces will be now in the opposite direction of the electric field, and the electric force is going to be in the opposite direction of the electric field before. Of course, they will be equal in size as well. Nothing's changing about that. So either the electron is going to be deflected. So you have the correct answer D. Now number 5. It says a particle of mass m and charge of magnitude q enters a region of uniform magnetic field B that is directed into the page. The particle follows a circular path of radius r. What are the sign of the charge of the particle and the speed of the particle? So let's see what is happening here. Let's try to work first with the speed of the particle. In order to do that, we need to work with the forces, of course, that they are acting on the particle. Now the force, it can be given by this formula, BVQ. Now you know that the particle is going to move in a circular path of radius r, so that means that this force, it plays the role of the centripetal force. So that means that mv squared over r, it will be equal with BVQ. So now from here, you see that this v squared, it cancels out this v, and you need to solve this one for v. So you have B times Q times R over mass. And this, of course, is your option A or B. Now let's see what is happening with the magnetic field. Now we need to apply the right-hand rule for a positive charge and see how it's going to move. If it will move in the same direction as we can see here, then of course the particle is positive. If it will move in the opposite direction, then the particle is negative. Now the right-hand rule, I'm going to remind you here, it is the middle finger, your point finger, and your thumb. Now each one of those, they give you a different variable. So here the thumb, it gives you the velocity, the point finger, it gives you the magnetic field, and the middle finger, it gives you the force. So if this was a positively charged particle, let's say that a positive charge enters here, so if you apply this rule, you'll see that the force is acting on the particle, it has this direction at the moment that it enters the magnetic field. So that means that if the force is in this direction, the positive charge, it will move like so. But we have a different motion, so definitely the particle is negative. So your correct answer here is B. Now number 6, we have two parallel wires, P and Q, are perpendicular to the page and carry equal currents. Point S is the same distance from both wires. The arrow shows the magnetic field at S due to P and Q. What are the correct directions for the current at P and current at Q? So what we need to see here is to find out where the current moves through these wires, that they are perpendicular to the page, and we see the magnetic field. The magnetic field of each one is going to be the same because they have equal charge, and probably the length is equal as well, but anyway. So now we need to find the direction of the magnetic field. So in order to create a magnetic field for both of them downwards, that means that the magnetic field of Q, it needs to have this direction, so anti-clockwise. The magnetic field of P, it needs to have this clockwise direction. So the fields, they will add together, and at this point S, it will give you the magnetic field all the way downwards. Now what we need to do here, we need to use the right-hand corkscrew rule, and in order to do that, you see that for particle Q, the direction of the current is out of the page, so either A, either B. For particle P, the direction is into the page, so either A, either C. Of course, the correct answer here is A. So that's all for today, guys. Study hard and good luck.